So we need to solve this system of equation by writing down them in matrix form and solving it using matrices. So let's see how we can do it. First of all, let's write down matrix A. So matrix A is basically just a matrix of coefficients of our equations. So here we will have, for example, our first equation is x minus 5y minus z is equal to 1. So we will just write, in the first row, we will just write down the coefficients from this equation, which is 1, negative 5, and negative 1. In the second row, we will write down coefficients from the second equation, which is 0, 1, negative 1. And in the third row, we are writing down the coefficients from the third equation, which is 1, 0, negative 5. Well, this is our matrix A. Now, what we need to remember is that the matrix, we solve a system of equations using matrices, using the form that matrix A times x is equal to B. We can write it down as our matrix A, let me just duplicate this, our matrix A, our matrix A times x, y, z. So that solution set which we need to find, those variables which we need to find. So these are 2 multiplied is equal to these numbers in our equation. So it's 1, 2, 1 matrix. Great. Now let's see how to solve it. So we know that our matrix x, y, z is actually equal to A inverse times B. So to A inverse times 1, 2, 1 matrix. Okay, so now we need to find the inverse of matrix A, and we will do that using the elementary row operations. So let's write down matrix A and identity matrix. So matrix A right here. Matrix A right here, and identity matrix right here. So here we have 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, now we'll just need to perform some row operations to get our answers. So what we're going to do, first of all, we are going to substitute row 3 by negative row 1 plus row 3. So let's see what our matrix will look like after this. So I'll just copy paste it and erase row 3. And now instead of row 3 we will have 0, because negative 1 plus 1 is 0. Instead of 0 we will have 5, because 5 plus 0 is 0. 5 plus 0 is 5. And instead of negative 5, we will have negative 4, because 1 plus negative 5 is negative 4. And here we will have negative 1, 0, 1. Great. Next operation that we are going to do is substituting again row 3 with row 2 multiplied by negative 5. So negative 5 multiplied by row 2 plus row 3. Let's see what our matrix will look like after this operation. So again, I'll just duplicate this and I'll erase the last line. So now here we still have 0. Instead of 5, we will have 0. and instead of -4 we will get 1. Instead of we will actually have -1 here again, and here we will have -5, and here we will have 1. Great. So next operation that we are going to perform is that substituting row 2 by the sum of row 3 and row 2, and substituting row 1 by the sum of row 3 and row 1. Let's see what we will get after this. So again, I'll just copy paste this here. So instead of row 1, we will have 1, -5, 0, 0, -5, 1. Instead of row 2, we will have 1, 0, 1, -1, -4, 1. Great. And the last operation which we will do is substituting row 1 by 5 times row 2 plus row 1. So let's see what our matrix will look like after this. Here we will have 1, 0, 0, -5, -25, and 6. So we get that this is equal to -5, -25, 6, -1. So this is actually our inverse matrix. We have found our inverse matrix now. -5, 1. So we can write down that this is our inverse matrix. And now using this inverse matrix, we can finally find the solution to this equation. I'll duplicate our formula again. Second, we don't need this. Okay, so we just need to write it down as this solutions matrix is equal to our inverse matrix times this matrix. Well, there is no it's not stated in the problem that we need to solve this, but in case if you need, you just need to do the multiplication of these two matrices, and you will get the answers, the solutions of your system of equations.